There is a mixture that costs $2 to make in your kitchen right now that brings dying plants back from the edge of death in 72 hours. Not with a chemical fertilizer, not with a branded plant tonic from a garden center shelf, with two ingredients that have existed in every pantry and every patch of soil on this planet for thousands of years. A single application to the root zone of a yellowing, wilting, root-bound plant, and within 3 days the leaves begin to straighten. Within a week, new growth emerges from stems that looked finished. Within 2 weeks, the plant you were about to throw away looks like it belongs in a greenhouse display. The formula costs less than a single packet of branded plant food at your local garden center, and it works not by masking the problem with a chemical spike of synthetic nutrients, but by rebuilding the biological foundation of the soil itself, the invisible ecosystem that every living plant on Earth depends on to survive. Garden centers across North America and Europe generate over $47 billion in annual revenue. The single largest category in that revenue stream is not seeds, not soil, not tools. It is plant care products, fertilizers, tonics, root stimulators, bloom boosters, pH adjusters, and proprietary soil amendments. A $2 mixture that renders every single one of those products obsolete is not an innovation the industry wants you to discover. It is a threat they have spent decades making sure you never find. This is the story of the formula, the one that ancient farmers built entire civilizations on, the one that military agricultural programs used to feed armies in the field, the one that professional horticulturists use behind closed doors while selling you a $14 bottle of colored water with a plant logo on the label. This is the knowledge that garden centers buried. And today, we open the vault. The suppression of this formula is not dramatic. It is quiet and far more effective for it. The global plant care products market was valued at $9.2 billion in 2023 and is projected to exceed $13 billion by 2030. That growth is not driven by innovation. It is driven by one ruthless business principle. Healthy plants that thrive on their own do not generate repeat purchases. Walk into any garden center and count the products targeting the symptoms of poor soil biology. Root stimulator, anti-yellowing formula, bloom enhancer. Each one a $10 to $30 bottle addressing a visible symptom. None of them touching the single underlying cause behind every one of those symptoms, the collapse of soil microbial life. A University of Illinois soil science study published in 2019 found that long-term synthetic fertilizer use reduced soil microbial biomass by up to 37%. That workforce cannot be replaced with a bottle. It can only be restored. And the formula for restoring it costs $2. Let me take you back to where this knowledge begins, not in a laboratory. In a rice paddy in the Yangtze River Delta 7,000 years ago, Chinese farming communities discovered something extraordinary about the dark, almost black soil that formed along riverbanks where decomposed organic matter accumulated in still water. Rice planted here grew faster, stronger, and more drought-resistant than rice in the pale, leached upland soil. They called it Wu-Tu, dark earth, and they did not simply plant in it. They manufactured it, deliberately composting plant material, fish scraps, and wood ash directly into their paddies, in a process archaeologically documented across the Yangtze Delta going back to 5000 BC. Without any knowledge of microbiology, they were rebuilding the biological complexity of their soil. They were feeding the microbes that fed the plants. China fed more people per acre than any civilization in the ancient world for thousands of years. The foundation of that miracle was a 2-ingredient biological principle that costs $2 to replicate today. Now travel west, to Roman Judea around 200 AD. The agricultural writer Columella, in his 12-volume work De Re Rustica, documented the practice of amending failing soils with a fermented liquid made from decomposed plant material steeped in water. Farmers filled clay amphorae with spent vegetation, poured in rainwater, sealed the vessels, and allowed the mixture to ferment for several days. The resulting liquid was dark, pungent, and cloudy with microbial activity. Applied to the root zones of struggling vines and olive trees, the results were dramatic. Yellowed plants recovered color within days. Root systems drove deeper into the soil as if following an invisible signal. Columella had no microscope, but he understood the outcome with the certainty of decades of repeated observation under Mediterranean sun. He was describing, in the language of a first-century Roman farmer, the restoration of the rhizosphere, the thin biological zone surrounding every root where chemistry and microbial life interact to unlock nutrients. Move forward to 1943. Allied military agronomists in Papua New Guinea faced depleted tropical soils and unreliable synthetic fertilizer supply lines. They turned to indigenous Melanesian farming practices involving fermented banana skins, fruit pulp, and wood ash steeped in water for 48 to 72 hours, then applied to root zones before planting. Field trials documented in reports later archived at the USDA National Agricultural Library showed germination rates 40% higher in biologically treated plots versus untreated control plots in the same exhausted soil. The military fed soldiers from those paddies. The formula worked. The reports were filed, archived, and quietly forgotten as the post-war chemical revolution rewrote the language of agriculture. Before I show you exactly what this mixture is and how to make it, I need to tell you about what else is inside the complete forbidden camping vault, because this formula is just the beginning of what they buried. Inside the vault, the $3 rust killer that the US military used on Sherman tanks in World War II, and that the auto parts industry has spent 80 years making sure you never find. The wood restoration liquid that turns gray, cracked, weather-destroyed timber back to its original condition for $2 in hardware store ingredients. The earth battery blueprint that generates real, measurable electricity from nothing but 2 pieces of metal and wet soil, documented by the US government in 1848 and erased from every modern survival guide. The acrylic resin formula that restores oxidized, chalky, sun-destroyed automotive paint to factory gloss for $3 at the hardware store. Permanently, no spray booth required. The solar water heater you can build from scrap parts for $20 that energy companies have been quietly lobbying against for decades. The biochar water filter that purifies contaminated water for under $15. The atmospheric water generator that pulls clean drinking water from humid air using nothing but salt and sunlight. Over 12 guides in one vault, no filler. Every page built for immediate use. The link is in the description right now. But do not go anywhere, because the science behind this $2 plant formula is the most important thing you will hear in this entire video, and what it reveals about the structure of plant biology is something the fertilizer industry has actively worked to keep out of mainstream consumer awareness for over 70 years. Here is what is actually happening in healthy soil that synthetic fertilizer destroys and this $2 mixture restores. The root zone of every plant is surrounded by a biologically active region called the rhizosphere, extending roughly 2 millimeters from the root surface in every direction. Inside that zone, microbial life is 10 to 100 times more concentrated than in the surrounding bulk soil. Plant roots actively secrete compounds called root exudates, sugars, amino acids, organic acids, that feed and attract specific microbial communities. In exchange, those communities perform functions the plant cannot do alone. Mycorrhizal fungi extend hyphae outward across several meters, accessing phosphorus, zinc, and manganese deposits that root hairs could never physically reach. Nitrogen-fixing bacteria convert atmospheric nitrogen into ammonium, the precise form plants absorb, without any input from a synthetic bag. Actinobacteria produce natural antibiotics suppressing soil-borne pathogens that would otherwise destroy root tissue. A landmark 2021 meta-analysis in Nature Plants, reviewing 41 independent field studies across 6 continents, found crops grown in biologically active soils showed 19 to 24% higher yield than identical crops in biologically depleted soils receiving equivalent synthetic nutrients. The $2 mixture works because it delivers a concentrated inoculum of that entire biological system directly to the root zone, bypassing the years it would normally take for microbial communities to reestablish in sterile potting mix or depleted garden soil. The 2 ingredients are mature compost and unsulfured blackstrap molasses. Compost tea, enhanced with molasses as microbial fuel, steeped 24 to 48 hours in oxygenated water. A study at Washington State University in 2004 measured bacterial counts in actively aerated compost tea, reaching 24 billion colony-forming units per milliliter after 24 hours with molasses added. 24 billion living organisms per milliliter, applied directly to the root zone. For $2 in materials covering an entire garden bed or dozens of potted plants. Here's exactly how to make it step by step, with materials available at any garden supply store, hardware store, or grocery store. Step 1. Gather your 2 primary ingredients. Purchase or source mature compost, either home produced from a compost bin that has been active for at least 3 months, or purchased from a garden center as bagged finished compost. Avoid sterilized or heat-treated compost, as the heat kills the microbial life the formula depends on. Purchase unsulfured blackstrap molasses from any grocery store or health food supplier. Confirm the label says unsulfured, as sulfured varieties contain preservatives that suppress microbial activity. A standard jar of blackstrap molasses costs between $3 and $5 and is sufficient for dozens of batches. Step 2. Fill a clean 5-gallon bucket with unchlorinated water. Tap water in most municipal systems contains chlorine or chloramine that will suppress microbial populations during steeping. Leave tap water to sit uncovered for 24 hours to off-gas chlorine, or use collected rainwater or pass tap water through a simple carbon filter before using. Step 3. Add 1 to 2 cups of finished compost to the water, place it directly in the bucket, or use a mesh bag or old pillowcase tied at the top to make removal easier at the end of the steeping process. Step 4. Add 1 tablespoon of unsulfured blackstrap molasses per gallon of water in your bucket. For a 5-gallon bucket, that is 5 tablespoons. Stir to dissolve. The molasses provides the carbon energy source that drives microbial multiplication throughout the steeping period. Step 5. Aerate the mixture continuously for 24 to 48 hours using a simple aquarium air pump with an air stone available at any pet supply store for under $10 and reusable indefinitely. The oxygen is critical. Aerobic bacteria, the beneficial soil microorganisms your plants need, require oxygen to reproduce. Without aeration, the brew becomes anaerobic and produces microbial communities that can harm rather than help plant roots. A healthy, actively aerated brew will develop a sweet, earthy smell similar to fresh forest floor. If it smells sulfurous or rotten, discard and start again with fresher compost. Step 6. After 24 to 48 hours, apply the finished compost tea immediately. Do not store it. The microbial populations begin to decline rapidly once oxygen input stops. Pour it directly onto the soil at the base of your plants, saturating the root zone. For potted houseplants, apply until the liquid begins to drain from the bottom of the pot. For garden beds, apply approximately 1 gallon per 10 square feet of planting area. For seedlings or newly transplanted specimens in transplant shock, apply a half-strength solution, 50% compost tea, 50% clean water, to avoid overwhelming delicate root systems. For severely depleted soil or plants showing advanced deficiency symptoms, complete leaf yellowing, stem dieback, root rot margins, apply at full strength every 7 days for 3 consecutive weeks, then reduce to once monthly for ongoing maintenance. Step 7. The safety note that most gardening channels skip entirely. Do not apply compost tea to edible crops within 60 days of harvest if the source compost contains any animal manure due to potential pathogen presence on the edible surfaces. For ornamental plants, houseplants, trees, and non-harvest vegetables, this restriction does not apply. Always wash hands thoroughly after handling compost and compost tea. The total cost of this treatment for a full growing season, covering a 200 square foot garden bed or 30 to 40 potted plants, is under $4, inclusive of the molasses and the compost. The aquarium pump is a one-time purchase that lasts for years. Compare that to a single bottle of branded liquid fertilizer at $12 to $18, which covers perhaps 20 applications before running empty, addresses only 1 or 2 nutrient variables, and actively degrades the biological foundation it claims to be supporting. A homesteader in rural Vermont documented her experiment with compost tea on a half-acre market garden that had been under synthetic fertilizer use for 11 consecutive years. The soil was pale, compacted, and biologically exhausted, producing diminishing yields despite increasing fertilizer inputs. She switched to a twice-monthly compost tea program in April. By August of the same year, her soil organic matter had increased measurably, earthworm counts per cubic foot had tripled, and her tomato yield per plant exceeded the previous season by 31% without a single application of synthetic fertilizer. Her total input cost for the season was under $20. Her previous synthetic fertilizer spend had averaged $340 annually for the same area. Now, you know what 99% of home gardeners, container plant enthusiasts, and backyard growers have never been told. You know that the yellowing plant on your windowsill is not asking for a $15 bottle of iron chelate. It is asking for the biological community it evolved to grow inside. You know that the struggling tomato in your garden bed is not deficient in the synthetic compound printed on that fertilizer bag. It is living in biologically dead soil that cannot unlock the minerals already present in the ground beneath it. You know that the $47 billion garden center industry depends on you believing that plant health is a product problem with a product solution, when it has always been a biological problem with a biological solution that costs $2 and brews overnight in a bucket in your garage. The garden center does not want you to know that finished compost and a tablespoon of molasses outperforms their entire fertilizer aisle. The fertilizer companies that supply those shelves have spent decades funding agronomic research built around synthetic inputs, publishing findings in trade journals that circle back to product recommendations, and training an entire generation of garden center staff to diagnose plant problems in the language of nutrient deficiency rather than the language of soil biology. It worked. For decades it worked. But biology is patient, and the microbes in a handful of finished compost have been rebuilding broken soils since before the first human planted the first seed. Share this with every gardener you know who has been told their plant is dying and that the answer is on a shelf with a price tag. Subscribe and hit the bell, because the next vault we open contains something that makes the fertilizer industry's suppression look like amateur hour, and you are not going to want to miss it.